What's up? I'm sure it'll take a minute to get some people going. So I'm sitting here putting this manifold together, and I just wanted to, kind of show you how much of a pain in the ass this is. It's pretty intricate. I'm eventually going to do a full video on this subject and different applications and stuff like that. This is RB25 twin scroll T4 manifold, and it's one of the more complicated ones that you can do, that's for sure. It has a lot of tight wrapping bends and stuff like that, so it can be a real pain for sure. Get rid of that, there we go, so I can actually see what I'm doing. Yeah, not too bad though. These kind of, you have to weld them in like an order pretty much. You can't just slap them together. You gotta like pretty much plan out where you're gonna do and where you're gonna weld. There's like almost nowhere good to set this camera so you guys can see what I'm talking about. So I might flip this around here. Yeah, there we go. And this is for R32s in general. But what's up, Placey VR? Not a bad looking setup. These fit really tight in the car, and they have almost no like bolt runner clearance, which makes it just a pain for everybody. It makes a pain in the ass for me to weld. It makes a pain for you guys to install, and it makes it a pain for me to plan out, which really sucks. This one came out pretty nice. The collector did anyway. Got some real good color in some of those welds and stuff like that. But it's pretty cool. Yeah. I don't have anything crazy set up on the TIG torch right now. I just got a regular old 17 with a number 8 gas lens. But that works pretty good for tacking and stuff like that. I'm almost out of argon too, so I'm running real low CFH just to get as small attacks as I can on here. But yeah, so I'll try and set this up somewhere decent to try and get a good shot of this while I build it. I don't know how long we're gonna live stream for, but you know, what the hell. Try and set it up on this. There we go. Yeah. So we got to get this last this number 4 runner or number 5 runner in here, and then I'll go ahead and move on to number 3 from there. But let's try and figure out what the hell we're gonna do. And this is a huge pain in the ass when you have gloves like this too, because sometimes holding all these pieces together while you're trying to get it fit is just ridiculous, and it almost never happens. And I mean, you almost have to take them off. Like, there's almost no point. I'm sorry in advance because there's going to be a lot of me walking around trying to get parts fit up. But this is literally how you go about doing it. You just grab pieces that you think are going to work. Unless you design it in a CAD software, which I've done in the past. Not necessary by any means. You can totally build your own manifold without doing that. Built plenty of manifolds without trying to plan them out first, which sounds ridiculous, but it's totally true. Now we're kind of shooting across here down into the number 5 port, and I'm already seeing that I'm going to have an issue with this stud hole right there. And that's what you run into, is trying to plot this stuff. And I mean, a computer software would help a lot, but you're also going to waste a lot of time trying to develop, you know, each individual runner, when it's sometimes it doesn't have to be that serious. You can just plot it and kind of, you know, almost guess on some of this. And a lot of the times it'll work really well. And I'm sure with experience like I have, that it comes more and more naturally, and I think of stuff easier. However, I mean, that doesn't mean somebody else can't go ahead and do it. But let's see. I'm going to tack that just like that. Mainly because I like how it looks. Gotta grab another 90 because I want to come down and up. Got some more straight sections. Yeah. So this is what I'm talking about. I mean, if you pop this runner right there, then you're gonna have a real tight spot in between there, and you're gonna have to figure some stuff out. It's totally doable, but it's just gonna be a pain in the butt. So yeah. Sometimes that's how it works out though. Like, there's no way around it. You just have to pretty much, you know, work with the positioning you got and hope that when you put a stud in there, you know, that it's going to work out. And it does take a lot of test fitting and a lot of like trial and error. But see, like that time, that's going to give us a real nice low angle. And I'm going to be able to just stick a straight section in there, which is awesome. All right, grab this. This is going to be a little too long. Swap that out. We got some play in here. You know, like you can get little gaps and stuff like that. It doesn't all have to be perfect, because I mean you can weld some of these up, no issues. I need a slightly smaller straight section than this one. There you go. This might work. Yeah. That'll be fine right there. So the other tip I can give you guys when you're trying to put these together in a reasonable amount of time is have a bunch of stuff pre-cut. You know, because I mean, being able to just grab an assortment of straight sections and bends, like a lot of 45s, a lot of like smaller half-inch, quarter-inch, 5/8 straight sections, and then that'll help speed up the process of trying to get this stuff fit up when you're first starting out too, especially when you don't really have a plan and you're kind of just feeling it out. Now I built a bunch of these twin scroll ones, and I've kind of redesigned it like 4 or 5 times. And that's not a bad thing. I mean, having them slightly different isn't a huge issue, because I know that the overall design that I have and the overall spacing that I have is going to work just fine. And so I'm not real afraid to kind of branch out and try new stuff. There's definitely things you got to keep in mind though, and that's location of the other parts in the car and in the bay. That, like in the RVs, there's a portion of the motor that sticks up about even with the flange, so you can't drop below this flange or even really run right off of it. Like you can't have a real steep turn right off the flange, because it's just not going to clear that portion of the motor. And then other things you got to consider, like wastegate placement. You know, this is a twin scroll, so we're going to have some kind of merger between them unless we run a single gate on there, which we could run like one gate on the back and one gate on the front. This customer asked for a single gate, so we're going to have to make a merge between the two, which could be kind of a pain in the ass, especially when you're thinking about location in the car. It doesn't always work out with the wastegate placement to the manifold, and I've had one in the past where I was guessing how big the gate was. I thought like, oh well, a Turbo Smart 50 millimeter gate is going to be pretty close to a big Tile 44 gate, and it wasn't. It was like different planets. And the Turbo Smart one was huge, and the Tile 44 was like, I don't know, it was still big, but it was had to be like an inch smaller overall, which I thought was ridiculous. But so that's all stuff you got to take into account. A lot of people would be like, oh, these aren't equal length or any, something like that. And we've done bench testing in SolidWorks with manifolds that were equal length and manifolds that were unequal length. And the advantage was so negligible, and the level of pain in the ass that it was to get it to fit in the car was astronomical. So no, I'm not super worried about equal length, especially in a turbo application. Maybe in an NA application where the flow rate and the pulses between the cylinders is going to really affect the overall power. However, in this case, it more comes down to how the collector is matched to the flange, and how long that the collector runners are. The longer the collector runner, the higher the velocity that the air will travel, because it's a straighter portion into the port. And because these are all equally matched, when they merge together, they actually create a Venturi effect between all the runners. And if you're not familiar with what a Venturi effect is if you have air flowing through the runner and a runner matches it, the air that flows through it will actually create a vacuum on the opposing runner. So in this case, the air flowing through this runner is going to create a vacuum as the air passes over this hole where they merge this port. It's going to draw the air out of this runner, and we've seen that in practice. And there's a way to test it. Is when you build the manifold, if you blow air into one of the runners, and the opposing runners, the ones that are matched in the twin scroll or in an open scroll, like if you have one right next to it, will actually create a suction on the opposing port. So like in this case, if I was to blow air into this runner, it would actually create a suction on this hole on the number 4 from the number 5. And that's how you can kind of tell whether or not you're on the right path to having a good flowing manifold. Especially if especially if it's going to be like a low volume manifold. If it's going to be like for something tiny, a 1.2 or something like that, that's going to be real key. It's the higher volume of exhaust gas that you're going to be flowing through the runner. It more comes down to volume and not necessarily to how the Venturi effect works, because the amount of volume is what's going to give you that spool. Like on a large diesel, it doesn't really matter how the manifold's set up. It's not as crucial. It won't make you as much power because the volume of air that's coming through it is so huge that it's pretty much going to spool it however it has to. It doesn't matter how much back pressure it has and everything like that. In this case, you know, a 2.5 liter RB25 is going to take advantage of something like this pretty greatly. And the power differences between a improperly merged and blended collector and a blended collector, or a nicely merged one like this where it's all going to match up and flow real well into the flange, is going to be huge. It's going to be pretty dramatic. You're going to notice it. And you're also going to notice it in spool. One of the ones that I built, one of the ones that I was selling for a while and that I was building for a while and then I stopped building because I just got sick of building them, was just the regular RB25 open scroll T3. And we saw improvements from people spooling larger GT 3070, 3076Rs from 4,500 RPMs down all the way to 2,900 RPMs is where they were hitting peak boost. One of the guys that we sold one to a while back, he was killing it numbers wise. He was getting like 400, I think it was 430 wheel horsepower, and like I said, it was making boost. It was making full boost, 14 pounds at 2,900 RPMs. So yeah, I mean, like, the collector really does help, especially if it's, you know, halfway decent. And that's the problem with a lot of those CX racing manifolds and stuff like that, is the collectors are so poor that they are vastly impeding what the manifold could produce. Like if you were to cut it off and rework the collector, I bet you it would work pretty well. Again, because the runner length is the more minor portion than the actual merge or collector. That's gonna be the biggest thing. So we're gonna get a couple more tacks on this just so that we can firm it up before we progress. And I'll go through and I'll blend and polish all these parts after I get them all tacked up, because we're gonna break all these runners back apart and then weld them out in entirety and then re-weld them back to the flange. So it's a real process. And right now I'm not back purging these runners, and the reason for that is, in this case, it's kind of a waste. And when you're just tacking stuff like this, unless you were to go through and wrap each one of these in tinfoil or wrap each joint in tape as you tacked it, you're gonna get some porosity. There's just no way around it. The real crucial part is when you go to weld it out, that you back purge the runner. That way, you don't go out of your way to make sugaring, you know, and porosity on the inside of the tube. You want it to be as smooth as possible. A little tack like that, a little quick tack like that, is not gonna affect the performance of the manifold. And I've been doing that the whole time I've been building them, and I've used to back purge them, and then I stopped back purging them because it just doesn't make a whole lot of sense. So yeah. Now we got to move on to one of the more crucial ones, which is number 3 runner, because if we don't put number 3 in, then we might be off on number 6, and we really need number 6 to be kind of out of the way. On the R32s, they have a lot more room for the downpipe, and next to the steering column than like an S13 or something like that. So in this case, we're not super worried about where the downpipe's going to go, but we are going to be worried about the number 5 runner, or the number 6 runner, excuse me, and the wastegate, because that will put you in a bind down the road for sure. So these, I'm going to start off with kind of angling this right off the bat away from the rest of the runners, because I want this thing to be as tight in this little pocket as I can get it. Kind of bring it up into here and then bring it around to this one. And something like that's probably going to work best for us. We may end up, I might end up putting a little straight section in there. I'm not going to have a lot of room for one. Probably a 5/8 straight section in there just to bring it even tighter into here. And this is what I was talking about earlier. I don't know how many people are watching right now. It only looks like we got one person watching, but earlier in the video I was saying have a bunch of cut stuff, and this is why. Because when you're in a bind and you need to have just try and get stuff done quickly, you don't want to be taking breaks to cut it and changing gears all the time. You want to just kind of cut and weld and cut, or fit and weld. You don't want to have to be going back and forth and cutting and welding every time. That gets real tedious and annoying. And I'm not sure how many of you guys are familiar with TIG welding, but I'm just doing quick little fusion tacks. I'm not adding any filler for the tacking and the runners. It's not necessary, and we need to keep moving through this. We don't want to be taking our time to try and hold 2 pieces while I add some filler or something like that. We want to just keep banging through it. Got some assortment here now, so try and work with this. This is what I was talking about, trying to get an idea of how you're going to fit it with gloves on can really, really suck. I got some cool pieces too that I've collected over the years. Just random pieces from other manifolds that I don't throw away for this very reason. Like this angled piece, it's just a straight piece of Schedule 10 1.25 diameter pipe, 304 stainless, and it's got a bevel on one side and a straight portion on the other, and stuff like that can really come in handy for when you're trying to make tight transitions. And in this case, it looks like it's going to position this runner real nice and tight up against this runner, which is ideal. So we don't have a lot of room on these, like I was saying earlier. On most of these cars, you only have 8 or 9 inches off the flange for clearance into the car, into the bay, off the motor. And R32s only have 9 inches between the flange and the strut tower. So as long as you stay within that 9-inch range and you clear the power steering on the front, you should be pretty good. But like I said, we want to keep it as tight as we possibly can. And you're not always going to be able to tack and hold this stuff. You're going to have to do stuff like this where you tack a couple of pieces together, because you're not going to be able to hold like 10 pieces and tack it all. It's just not realistic. I've definitely got myself in binds that way, trying to do stuff like that. And like I said, it can be a real pain in the ass to do some of these. So not something you want to make more difficult. You just want to make it as simplistic and fit as well as you can. And I don't have like a real good end game on this one. I'm just kind of plotting it out, kind of knowing where I need to be. I need to clear this runner and I don't want to be real high. So I'm going to get this kind of, again, as tight as I can. And you won't get these first shot. Like most of the time, it takes a couple of them. You know, you got to work with it, rework it. You can't just jump into it and expect to have it fit all at once. Okay, so we got this one. That's kind of cool. It kind of dips down and moves over here, and we should have no issues getting these lined up. I think like a 90 right here. Yeah, see? I mean, that's pretty damn close. That's not far off at all. And you can manipulate these, like rotating these and clocking these 45s and 90s is how you're going to get to where you need to be. And a computer design, like a pre-computer design program is kind of nice for stuff like that, but it's also a pain in the ass. Because you're like, well, it's telling me I got to clock this 90 23 degrees from the other one. How do you measure that? Like, how are you going to be like, oh, okay, 23 degrees? Unless you mark each one of these out, you know, and make it your own degree marker on these, you're not going to know that. So I mean, you almost have to come down to like doing stuff like this at some point. The other thing we could do is kind of 45 into this 90 up here, and that might get us a better shot on that. I'm going to grab some more. Notice how fast I'm going through tube here. So I got some 45s. Kind of like looking at this like this, yeah. We got a little bit of an off canter. And you can cut these down in different things. These are just cut into 45s for good reference. And there's no reason why you couldn't cut this down to a 30-degree portion of this 90, and that's all this is 45 degrees off of this 90. So you could cut it down to whatever you needed. If you needed a 60-degree, 50, whatever. You know, as long as you have the jig to cut it, you can get it down to where you need to go. However, I have found that 45s can pretty much be rotated and manipulated into whatever shape you might need. Now, like, this is a little long and a little wavy, and this is all just 45s, but I don't mind having it a little longer and a little wavier if it only took me 5 minutes to put the thing together. If it's going to take me 5 days to get this one runner done, then it's not worth it to me. And a lot of these runners you could almost entirely make out of 45s just because how flexible they are, and you can manipulate them down into the exact shape you need. If you clock them all differently, they can all fit real well. You do run into a lot of welding with the 45s because, you know, like you could probably come up here, bend this at a 60 degree and straight shot this to there. Again, but then I would have to sit here and cut a bunch of different pieces to see which fits, and this just went together real quick. Probably need one more 45, maybe a small spacer. For the people we do have watching, I think there's 3 or 4 of you guys. I can't see your comments, so I'll make sure to answer them after the video. Yeah, so this is looking like it can almost entirely be made of 45s, like I was saying. You will run into spots where it fits better with a straight portion on one side than it does on the other. And you may have to take more time to clock it and mess with it than you think. You know, like it might fit with a random piece over here better than it does on that side for whatever reason. can be pretty tedious, and you got to just kind of practice and take your time. And eventually you'll get it to where it just looks like it's going to line up perfectly, which is kind of like right there. It looks pretty damn close. And then it comes back to what I was talking about earlier, is having to tack a bunch of stuff and then work with what you got. So like I'm going to hold this, put my helmet back on, and give this a tack real quick. Yeah. So now I got this all fit. I got this. That's hot. Now, like what I was saying before, I got a little bit of play in some of these. You know, a couple of these joints aren't welded all the way out. They only have one tack in them, so I can kind of manipulate them a little bit. I got a little bit of wiggle room. I try to avoid that as much as I can because I want to keep as tight a tolerance between the two as possible. And I know you guys probably can't see that super well, but that is like almost dead nuts on right there. Like we can stick a 5/8 piece in there and have it be good. Yeah. Grab another 5/8, flap it in there. Bam. And that's what I'm talking about. That's why the 45s are so nice, because you can just manipulate them into a runner pattern that's going to work right off the bat. And what's happening there is my tungsten isn't super sharp because I kept touching it while I was tacking. So I got to go ahead and sharpen that real quick so I can get a nice good tack on that one. Whew, that's hot. There's a lot of good tricks for sharpening tungsten. There's a lot of tungsten grinders out there on the market. I haven't got up the nerve or the courage to spend the $300+ on a tungsten grinder because it just seems ridiculous to me, especially when you can get a $90 grinder, like a brand new bench grinder, and use your drill and get the same exact results. That's what I'm talking about. That's all it takes. It's good and sharp. It took all of 15 seconds, not even. And we'll be able to get some decent tacks on this now. I would definitely go on a little tangent here and say that this is not your first. This should not be your first welding project. You got to be very confident in your abilities. Before you progress into something like this. I can't imagine trying to learn to weld while learning to build a manifold. It's just ridiculous. I've seen a lot of people, and that's why they want to learn to weld, or they do like a log manifold or something like that, and that's their first project. And that stuff drives me nuts. It just drives me nuts because there's no way you're going to be successful like you would if you just practiced welding and then you practiced building manifolds. We don't have a super lot of options on this runner setup because of the placement. You know, there's just not a lot of room. We could probably try and get a 45 in here to maybe tighten this up. So what you can do is you can use these bends in combination and really get a tighter radius that puts you in a different spot than you would have been if you just kind of like, oh, I'll use a 90 and then I'll straight. I mean, you're not going to get super tight that way. What's up? Let's look at these comments real quick. I'll take a break from that. All right. Sorry, hold on. Flip this around. There we go. All right. It says, great info, man. Nobody ever thinks about Venturi. I started understanding this from two strokes where the engine itself is, it's a Venturi. Yeah. So, I mean, a Venturi effect in a manifold is huge. It's going to give you the best overall performance versus having something equal length. And a lot of those quote unquote equal length long tube headers are not equal length. Like, there's no fucking way. I've seen them labeled equal length, and I'm staring at the thing thinking, how on earth can you guys even advertise this to be equal length? Because it's just ridiculous. But the way that they get away with it is the performance is better over the stock one because of the collector and the tube diameter, not necessarily because it's equal length. And then, you know, everybody wants to get hung up on the equal length part. But like I said, it's more comes down to Venturi, more comes down to the how the collector is built and everything like that. So I'm going to set it back down. I'm going to get back to work. This thing's a pain in the ass. All right. There we go. Oh, shit. Oh, cool. All right. So we got some more bends. We got this. Stupid little burrs that I didn't clean off because I'm dumb. Grab this 45. Grab this. Like that. And I'm kind of where a 90 would have worked. These two 45s will work better. Because I can clock it in the middle of the bend and reduce the radius, however, put myself in a better position than I would have been. You know, a 90 would have been a tighter radius, but it's not going to hug the inside of this runner like 245s will. That's kind of good right there. Might clock it up just a little bit so that it's not touching. Put my helmet back on. Get some more tacks on this. Yes, I know I'm not using gloves. I don't think anybody's commented that yet, but it's really hard to weld this stuff and get it fit without gloves. Or with gloves, excuse me. Alright, reposition here. Yeah, there we go. So now we're kind of getting ourselves to where we need to be. I don't want to come way out here and block my exit for a downpipe, even though I said earlier the R32 has a lot of room for a downpipe. That doesn't mean we want to take all the extra room out of the way for the downpipe, so we got to really be cognizant of that. I don't know if I quite like how tight that is. I mean, that might work pretty well, actually, because if it comes down, if we put another one right here, that's the whole thing, is you got to have an imagination for this stuff. If you're just sitting there saying, well, I don't know where to start, I mean, this is a great way of doing it. Just have a bunch of stuff cut, start figuring it out, start learning what works, what doesn't work. See what I mean? That looks pretty good. It's not ideal runner velocity, but then again, like I talked about earlier, it's going to come down to more the collector than anything. What this will do, though, however, is keep us clear of the steering column and keep this thing real tight together. Yeah. I'm kind of liking that. Kind of liking how that's fitting up. Again, not ideal runner velocity and probably not ideal flow rate, which is another thing that is a huge misnomer. A fraction of the manifold builders and exhaust header builders flow rate their stuff. Most people do not. So if you're looking to buy one from somebody and you ask them if it's flow rated, some companies will say yes, and other companies will probably laugh in your face because it's just not realistic. There's not a lot of ways to bench test this, and I'm sure that there is a way to bench test it, but the cost of bench testing it is probably outrageous. I think I'm gonna tack that shit right there. Okay. And we got to be looking at this too, because we want to clear right over top of this runner. Don't want to get ahead of myself. Kind of looks good right there. Okay. It's looking pretty good. It's kind of a cool look. It's a lot different design than I did last time. I'm sure it'll work just as well. Some of these get looking pretty wild, pretty octopus-like. Me and Chappie like to joke around that it's the flying spaghetti monster. Got ourselves more 45s, more 90s. Sometimes when you have a tight bolt-up location, it can be a real pain in the ass to get it to where you can still get a stud in there, still get a nut in there. I mean, I'm guilty of doing it. I built one day. I built the whole damn thing, and then one of them, you know, you couldn't get a stud in. So it's something you just definitely got to think about when you're first building them. Kind of liking that right there. That's going to give us good bolt hole clearance between these two. Yeah. Kind of liking that. Something along those lines. That'll give us some really good, maybe not the 90. More 45s. Yeah. Love them. Something like that's going to be pretty cool. We don't need a super aggressive bend out of here. As long as we keep it rotated where that bolt hole is going to be good. And sometimes it's good to position something and force yourself to work with it. Like, you know, I'll be building stuff on the fly like this, and I'll know that I need to put a bolt here, a stud here, and I'll try and, like, you know, convince myself that it's going to fit. So if you take a piece of tube that's the only way that's going to work, and you tack that thing and you move on and you work with it how it is, you know, sometimes that's your best bet. It really depends on your personality. I have to force myself to do some stuff. And I know that, so I'm just gonna work with that. Work with the flaw, I guess. It's not gonna clear super great right there. I don't know how much longer this one is. This one's super long. Yeah. Oh, okay. So now this is gonna kind of clear this runner, but be right on top of it pretty much. And the downpipes on these cars, like I said, they come right down here. Sometimes I built them to where the 90 is like this, and then it cuts back around. I don't know how well you guys can see that actually. Oh yeah, you can see it. The 90 cuts back around, but that's actually a real, it's just as bad really for the clearance than trying to just kind of hop over this piece of tube. And some of these I will have to re-brake because you can see on here that there's a bevel, like a machined bevel. And some of them I will have to re-brake and then kind of refit and weld. Yeah. And this kind of looks like it's one of those times where a little bit of a bent one or a not super flush one would be really nice. Like one that's got a nice bevel on it, because this angle between this tube in relation to this tube is not drastic, but it is enough to where it looks like it would kind of be a pain. And almost looks like it kind of straight shot it right there. And that's pure coincidence, and that's what I'm talking about. Like, that's super close. I mean, I just grabbed that off the table, you know? Something to be said for having scraps to give you an idea of where you need to go and where you need to be. Like, damn. Super close. Super close. So I'm not even gonna fuck with that. I'm gonna just try and make that work. Get a tack on this real quick. That sucked. That's what happens too. You're trying to fit and hold pieces. You're going to touch tungsten occasionally. We got a little bit of wiggle room in this. This one has some bends in it. Rotate these around. And we'll try and get this positioned. I don't know if you guys heard that, but dinner's ready, so I might have to go here soon. I'm one hungry dude. All right. God, if that was right there, that would be perfect. That would be super perfect. Yeah. Shit. I wonder if we can just choke up on any of this real quick to get some of these to cooperate a little better. Looks like it needs to be a little bit longer. Maybe 1/8 of an inch. Yeah. And you can kind of see it. It's pretty close. We got these tweaked a little bit, but the gaps are all very minimal still. They're a little bit off kilter. We might have to fuck with that a little bit, but that's pretty close. I'm sorry, I'm blocking your view with my helmet. Yeah. I like that. I can dig that. That's pretty cool. Well, let me see here. Flip this around. I hope you guys get the idea of what I'm talking about and what I'm trying to do. I mean, we pretty much built the last 3 runners in the last 49 minutes. So it doesn't take very long to get far if you have this stuff pre-cut like I've been talking about. I know I'm preaching, I'm standing up here, you know, spouting off, but it really comes down to it. The proof is in the pudding. You just watched me bang this out. And I only had 3 runners done. You can really go a long way with just having stuff preset and pre-done. So I'm going to head off to dinner. I hope you guys enjoyed the live stream. Sorry if I wasn't really apt to answer a whole lot of comments. If you guys have any questions or want more information, go ahead and comment below, and I will be sure to get to them. You guys have a great night, and I'll talk to you guys soon. Bye.